reactions, and then we're also going to use the equation, a chemical equation, to find the moles of product and moles of reactant. Okay, and then we're also going to talk about this thing called the mole ratio. Okay, so an oxidation reduction reaction, I think there's just one Alex topic on this. So an oxidation reduction reaction moves electrons. Okay, so electrons are moving from one compound to the other compound. I use this acronym. Oxidation is loss, reduction is gain of electrons. So oil rig, that's how I remember it. I've also heard of Leo-Ger, which is loss of electrons. Leo. Loss. What is Leo-Ger? That one also has on Leo. Maybe I can't remember that one right now. But there's other ones. So if you hear another acronym. Oh, okay. There we go. I got it. Loss of electrons is oxidation. Gain of electrons is reduction. So that's another acronym. So I just remember oil rig. That one makes more sense to me. And that's how I remember. Oxidation is losing electrons. Reduction is gaining electrons. And this took me probably like 3 years before I can, now I just remember oxidation is loss of electrons. But before that, I had to use the acronym. Okay. So oxidation is loss, reduction is gain. So in the Alex topic, you're going to have to pick out which compound is oxidized and which one is reduced. Okay, so what we're going to do to figure out which one is oxidized and which one is reduced, we need to figure out the charge on each of the metals, and then if the charge is, that's called the oxidation state. The charge on the metal is oxidation state. Solid metal has an oxidation of 0, and then elements that gain electrons are reduced. Elements that lose electrons are oxidized. So the other way you can look at this is if the oxidation state is increasing, you're losing electrons, that's oxidized. If you're going from 0 to +3, you are losing electrons, that's oxidized. If you're going from 3 to 0, then you're gaining electrons, that's reduced. So let's look at an example. So here, this is aluminum solid. If you have a solid metal, that's going to have an oxidation state of 0. And then if we look over here, we have CuCl. If I look at chlorine, I don't know the oxidation state of copper yet until I look at chlorine. Chlorine has an oxidation state of -1. That's the charge, okay? We've talked about that, we know that, right? So copper must be +1 here. And then we go over here. So these are our products. Aluminum now has an oxidation state of +3. Copper is solid copper, so now that's a metallic copper, it has a charge of 0. So the aluminum here goes from 0 to 3, so it's losing negative charge, it's becoming positive. This one's being oxidized. And copper here goes from a positive charge, it doesn't have electrons too, we're getting one more electron, now it's a neutral charge, that's reduced. That's R. Okay, so that's all you have to do, you just have to figure out the charge on each metal, and then see if the metal is oxidized or reduced. Questions on that? Okay, let's look at some examples. Go ahead and see if you can figure out which one is oxidized or which one is reduced for each. So that you're always going to have one metal that is oxidized and one that is reduced. Okay, I don't want to spend too much time on this. Let's go through the first one. So zinc is a solid. What is the charge? 0. Okay, how about this one? What's the charge on silver? Always +1 here. Yep, so silver is +1, nitrate is -1. They need to balance. All right, how about over here? What's the charge on zinc? We can figure that out from this counter ion. So we have a minus charge. Nitrate is minus. We have 2 minus charges. So this has a -2. Yep, this zinc has to be +2. And then silver is a solid. That means it's 0. So let's look at zinc. From here to here, the oxidation number increased. That means we are losing electrons. So think about electrons are negative. We're getting rid of electrons. We're losing electrons. So this one is oxidation. Okay. The other one must be reduced, but let's think through it. So we have a plus charge. Now we have a 0 charge. We're going to, if we add 1 electron to silver, then it's going to have a 0 charge. So we're adding electrons, we're gaining electrons, it's reduced. Does that spell it right? So the other way you can think about this is the thing that's turning into a metal is going to be reduced. The thing that's changing from a metal to a complex, zinc nitrate, is going to be oxidized. Yes.
So how do you write it? Do you write like the whole thing, like the CN2, or do you just write NO3 for like the thing that's being oxidized?
Oh, let's look at the Alex topic. It depends on if it's asking you about the metal or the complex, the compound. It has been a while. This is chapter 5. This is called identifying oxidized and reduced reactants in a single displacement reaction. So for each reaction, write the chemical formula of the oxidized reactants. So this is the chemical. So we're looking at the reactant. So the reactant, that is oxidized. So that would be, let's look here, we got iron has a 0 charge. Yep. Here, because it's a solid. Lead, nitrate has a -1 charge, but there's 2 of them. So this is overall, that's going to have a 2- charge. So Pb has to have a 2+ charge. And then if we go over here, well, now Pb lead is 0 charge. Iron is now 3+ charge because we have 3 minus charges from the nitrate. So iron going to iron 3+ is going to be which one? This one is we're losing electrons. We started at 0. We're giving away negative charge, so we end up with a positive charge. So this one's being oxidized.
Wait, what do you mean we're giving? I thought we
Yeah, it's confusing because we're losing negative charge and it ends up positive. So the other one, lead, we are gaining electrons, so this is reduced. So this one's reduced, this one's oxidized. So let's see what we type in here.
How are we gaining electrons if it ends up at 0?
So it started with a positive charge. Electrons are negative. So if I give lead 2 electrons, then it will be at a 0 charge.
Okay.
And so this one I would just put the oxidized, I would put, oh, I didn't start it. Dang it. Well, I would put iron. I didn't realize I haven't started this one. Okay, so I type in iron, Fe. If it asks for the reduced thing, I would have to type this whole thing. Pb, NO3, parentheses 2. I'd have to type that whole thing.
So do we just ignore the coefficient in front of it?
Yep. Yes, ignore the coefficient. Yes, that's not part of the formula. Okay, very good. Questions on that? All right.
Wait, so how do we know that it ends up at 0? If it turns to a solid?
Yep, solid metal is going to have a 0 charge. That's a property of the metal. It has a 0 charge. Okay, other questions? Okay. All right, so when we have a balanced chemical reaction equation, this is telling us the number of molecules that we need to put together to get a final product. It also tells us the ratio. So we can think of this in terms of number of molecules or number of moles. So this is telling me I need 1 mole of nitrogen for 1 mole of oxygen gas gives me 2 moles of nitrogen oxide. Okay, so we are going to use that ratio to figure out, this is also a conversion factor. If I have this many moles of nitrogen, how many moles of NO gas could I produce? Okay, so these are the mole ratios that we can get from this equation. I have 1 mole of nitrogen for 1 mole of oxygen, 1 mole of nitrogen for 2 moles of NO2 or NO, and 1 mole of oxygen for 2 moles of NO. So I'm just using this coefficient in front of here to get those mole ratios. This is a 1. Okay. So 1 to 1 gives me 2. All right. And we can get from moles of A to moles of B using this mole ratio. So this chapter is a little bit tricky. It's just all conversion. So if you feel pretty good about conversions, it's just conversion factors. If you don't feel really confident in that, then just make sure you practice these, especially in ALEX. Okay. So this is an example of a problem that we might come across. So we have a balanced chemical equation. Make sure in ALEX you check and make sure it says it's balanced. If it is, then you don't have to worry about that. Sometimes it will make you balance it first. So just watch for that. So this one says, using the balanced chemical equation, how many moles of CO are produced from 3.5 moles of C2H6? So what we're going to do is we just take the number that we start with. We are given, this is our given value. In our conversion problems, in chapter 5 especially, we just start with our given value. So I have 3.5 moles of C2H6. And then I'm going to convert that, so I need a conversion factor. And I'm trying to figure out this, how many moles of CO? So I need to end up with moles of CO. So we can just use our strategy. We're just figuring out what goes on the top of our conversion factor, what goes on the bottom. So what would go on the top of our conversion factor? Moles of what? Good, moles of CO, because we need to end up with that at the end. And then moles of C2H6 needs to end up on the bottom because we need to cancel that out. And then we find the numbers from the balanced chemical equation, from those coefficients. So what number should we put in front of CO? 4, good. So 4 moles, CO is right here. We just pick up that number and we put it there, okay? And then we need moles of C2H6. Good, and that just comes from, we find C2H6. This is telling us for 2 moles of C2H6, we should end up with 4 moles of CO2. And we're just figuring out this ratio. So 3.5 moles of C2H6, our moles of C2H6 will cancel, and then we just do our math, and we end up with moles of CO. So writing these problems out, making sure that your units cancel, that's going to be really important. Okay, so then if I do this on my calculator, 3.5 times 4 divided by 2 is 7, but I use this as my sig fig value. Okay, these are just the exact numbers. Like if I have 10 fingers, that doesn't really have sig figs. This is not counting towards our sig figs. So I would write 7 point, I don't know, I just put 5. 7.0. I just need 2 sig figs, 7.0 moles of CO2. So this is telling me, based on this chemical equation, if I start with 3.5 moles of C2H6, I should end up with 7 moles of CO. Okay, questions on that? All right. Okay, there are a few questions here. Go ahead and try the first one. So this says, using the balance equation for the combustion of acetylene, that's acetylene, answer the following questions. So the first one is, how many moles of oxygen are needed to react completely with 5 moles of C2H2, which is acetylene? So see if you can figure out, we have this many moles of C2H2, you're trying to find moles of O2. Alright, how are we doing on the first one? We need some more time? Are you ready? More time? I can't tell. Ready?
Yeah.
Ready? Okay. So when I do these, I just write out what I know. So where are we going to start here? Good, 5.00 moles of C2H2. Okay, and then we know we need a conversion factor. What are we trying to end up with? Good, moles of O2. So then what will this is called our mole ratio. What goes on in our mole ratio? What will go on the top? 5, good, so we need to end up with moles of O2, so this 5 comes from here. 5 moles of O2 for 2 moles of acetylene, which is C2H2. So then I'm going to check my units. Moles of C2H2 cancels, and then moles, we end up with moles of O2. So we have 5 times 5 divided by 2, and we need 3 sig figs. So that's going to be 12.5, good. So if we start with, according to this chemical equation, if we start with 5 moles of C2H2, we should end up with 12.5 moles of O2. Okay, questions on that? So we have 3 more we could practice. Do you want to keep practicing? Do you want to do another one? Okay. Do you want to do another one? Yeah. And then, okay, then we'll go back over it. Okay, go ahead and try the next one. All right, are we ready to do the next one? Together? Yes. Okay. Okay, help me set this one up. How do we set this one up?
6.0 mole of C2H2.
Okay. This is okay.
Mole CO2 divided by mole C2H2.
Sorry, I don't have enough space here. Moles of C2H2. Okay, and then what are the numbers that go here?
4 and 2.
Okay, 4 on the top and 2 on the bottom. Okay, and we just grab that. 4 moles of CO2 for 2 moles of C2H2. Okay, and then what did you end up with? What's your answer?
12 moles CO2.
Okay, and then this one is one, we just have, where is it? 6, right? We have 2 sig figs, so we're just going to put 12 decimal place. 12 moles of C2H2, or CO2, excuse me. CO2, because those cancel out. Okay, good. Do you think that you could do this on Alex? Yes. Okay. Okay, we're going to keep going, but if you need some more help, especially on the Alex topics, I can. And there's also these examples are written out. Okay. So this is another type of problem that you might find in Alex. So it says, using the balanced chemical equation, how many grams of O3 are formed from 9 moles of O2? So this one you have to, this is a 2-step conversion problem. So let's write out what we know. So first we know we have 9 moles of O2. And this one, we are trying to figure out how many grams of O3. Okay, so to get to grams of O3, we need to use, first we need to use the mole ratio to convert O2 to moles of O3, and then we're going to use the molar mass or the molecular weight, either of those mean the same thing, to figure out grams of O3. So the first one, we're trying to just convert moles of O2 to moles of O3. So our equation is going to give us those ratios. So I need to cancel out moles of O2, so that's going to go on the bottom. And I have 3 moles of O2 for 2 moles of O3. And then I need the molar mass. Do you remember how to find the molar mass? And we're looking for the molar mass of O3. Yeah, so I'm going to add oxygen is like 15.99. And we have 3 of them. So if I add that up, that's going to be the molar mass. And I need grams at the end. So the grams part will go, grams of O3 will go on the top for 1 mole of O3. And then moles of O3 cancels, moles of O2 cancels. And we will end up with grams of O3. So I'm going to find the molar mass. 15.999 times 3. Oops. Sorry? Oh, thanks. Okay, and then we just multiply through. So we're going to multiply across the top and then divide. So 9 times 2 times that number that we just got. Divided by 3. And that gives us how many grams of O3. We have 2 sig figs, so we should end up with 2 sig figs. So I'm going to move my decimal twice. So 2 point, round up, 2.9 times 10 to the 2 grams of O3. Okay. The other class wanted some conversion charts, so I printed them some off. So I will also print you guys some conversion charts as I'm on top. And then you can, this kind of helps you. So if I'm going from moles to grams, you can figure out which conversion factor. Or you can just figure it out based on the units. Okay. Why is this one on nine? Okay, twice. Okay, so this is another, I would like you to try the first one. Using the balanced equation, answer the questions. So just do the first one first. We have this thing plus 3 oxygens gives us 2 CO2 plus 3 waters. How many grams of CO2 are formed from 0.05 moles of ethanol? That first thing over there is ethanol. I can write that. So see if you can, so remember two-step conversion. Mole ratio, then use the molar mass. right, do we need another minute? Okay. Should we keep working on this one? Are we ready? Okay. So we're gonna start with this, right? 0.05 moles of ethanol, which is C2H6O, and we need to end up with grams of CO2. Good. So the first thing we need to convert is from moles to moles of ethanol to moles of CO2. So what will our first conversion factor look like?
2 moles CO2.
Good.
1 mole C2H6.
Good. Okay, good. So that moles of CO2H6O will cancel. And then what's our next conversion factor? Good, we need grams on the top, grams of CO2, that's what we're trying to end up with, over moles. For 1 mole of CO2, we need to know how many grams that is. And so then we just add 1 carbon plus 2 oxygens, and then somebody calculate that.
14.076.
Okay, and then right here, moles of CO2 cancels, and then if we multiply across, and we don't have a border, 0. We don't have anything to divide by. Okay, and you have, this one's weird, that's probably fine. This one really technically only has 1 sig. So we would probably go with 4 grams. 4 grams of CO2. Okay. I thought this was an Alex topic, but I'm looking back through, and I don't think that you have to do that. So this is like if you took Chem 1210, you have to do this.
There's a Chem 1210.
So if you're going into engineering or chemistry, then that's the one that you will take. Yeah, I don't think that this one is one. But just know that you can do this. Sorry?
The chemistry 12.
They don't have it at bottom.
They have it at Weaver State though, right?
So just like a little deeper. We're just kind of like skimming the surface. That one goes home. You guys are not moving around enough. That's why our lights just turn off.
That's not working right away.
Okay, so there's some on it. Okay, we're gonna keep going.
I can do that.
Yeah, we're gonna skip this. This isn't an Alex topic. But know that if you take like a more advanced chemistry class, you have to go from grams of your reactant 2 moles of reactant to moles of product to grams of product. So you could go from grams of one through your chemical equation all the way to the end. But our class, the Alex topics, you don't have to do that. This wasn't in the slides for this class, but you don't have to do that, so you can skip it.
So yeah, I'm gonna get a full conversion.
Yeah, you need 3 conversion factors. Yeah, so if you master like what we have to do in our class, that'll help you if you have to go on and take more like Chem 1210, or if you take like physical chemistry, or if you take like physics. There's a lot of conversions in physics. Maybe not with chemicals, but with like units. Or if you take like thermodynamics and engineering, like with lots of conversions. So you just have to make sure everything cancels out. Okay, that is our notes for today. We have like 20, how much time? 30 minutes. We got 30 minutes. Please, if you want to do lab 4, work on lab 4. That's due next week. Make sure you have pre-lab 6 for next week. Thursday. What else? And then make sure that you're working through the Alex topic. If you have questions, you've got 1 day left of notes. So we have a few topics left that you want to do.